Hey everyone, Stelvio here. Welcome back to the channel where we break down data architecture and everything in between. If you are into database and tech, make sure to hit that subscribe button here below, like this video, and share with your datamates. Today we are diving into the world of databases, but not just any databases. Look at that. There are so many types, relational, graph, time series, NoSQL, vector, blockchain, and more. But what do they all mean? And more importantly, when should you use one over another? Stick around and we unpack all the different kind of databases, explore real-world use cases, and help you to choose the right tool for your data-driven solution. Let's go. Moving on to the new SQL databases. What exactly is a new SQL database? If you're looking for the power of traditional relational databases with the scalability of NoSQL databases, this is the database for you. New SQL databases are a modern evolution that combines a relational database feature, which we all know and love actually, with the scalability typically found in a NoSQL database system. New SQL databases are typically used in cloud-based applications that need to maintain high availability and handle large volumes of data. These databases are perfect for situations where you need horizontal scalability, meaning the ability to distribute your data across many servers, and still want to run SQL queries for complex operations. This makes new SQL ideal for applications that need both high performance and relational features. Our examples of new SQL databases include Google Spanner, for instance, or CockroachDB and NuoDB. These databases are designed to support scalable, highly available applications while maintaining the consistency and querying power that SQL usually provides. Another famous example is Google Search or Google Cloud Services. So to summarize, the new SQL database brings together the best of relational and NoSQL words. They combine traditional SQL features like ACID compliance and relational queries with the ability to scale horizontally across many servers, making them perfect for cloud-based high availability applications like Google Spanner and others. Let's now talk about the time series databases. Whether it's sensor reading, metrics, or financial data, these databases are designed to make working with time-based data. So let's dive in. As the name suggests, time series databases are optimized for storing and querying data that is collected over time, timestamped data. This includes things like metrics, logs, sensor data, and even financial data. Basically, any data that changes over time. Imagine you're tracking sensor data from IoT device. For instance, every minute this device sends data like temperature, humidity, along with a timestamp. Time series database allows you to store this data efficiently and query it in a way optimized for time-based analysis, such as finding trends and aggregating data over specific time periods. Some of the most popular time series databases are InfluxDB, TimescaleDB, and OpenTXDB. These databases are specifically built for handle large amounts of timestamped data, making it easy to store, query, and analyze time series data efficiently. A great example of a famous application that uses a time series database is real-time monitoring in cloud infrastructure. Platforms like Netflix, for instance, use time series databases to monitor the performance of their cloud systems. They track millions of metrics like server CPU usage, response times, and database performance over time. This allows them to quickly spot issues, predict future problems, and optimize the infrastructure for better performances. So to summarize, time series databases are optimized for storing and query time-stamped data, making them ideal for applications that need to track metrics, sensor data, logs, and financial informations. Examples like InfluxDB, TimescaleDB, and OpenTXDB are excellent tools for handling this kind of data, especially in real-time applications like cloud infrastructure monitoring. Alright, and what about spatial databases? These are databases that are designed to store and work with geographic or spatial data. If you have ever used a map app or wonder how location-based services work, you are about to get a behind-the-scenes look at how it all happens. So let's jump in. A spatial database is a specialized type of database designed to store, query, and manipulate geographic or spatial data. This kind of data refers to anything related to locations, geographic coordinates, or shapes. Imagine you are using a mapping application. Each place on the map, whether it's a city, a street, or park, is represented by geographic data like latitude and longitude coordinates. A spatial database allows you to store that data and, more importantly, query it efficiently. This means find all the places within a certain distance, calculating routes, or analyzing spatial relationships like whether a point lies within a polygon. So spatial databases are commonly used in geographic information system, GIS, location-based services, mapping applications, and even geospatial analytics. For example, in a GIS application, spatial databases are used to store layers of geographic data like roads, or rivers and property boundaries. In location-based services, they help power apps that tell you the nearest coffee shop or show you the best route to your destination. Some popular examples of spatial databases include PostgreSQL, which is an extension for PostgreSQL, Oracle Spatial, Microsoft SQL Server Spatial, and SpatialLite. One of the most famous applications that rely heavily on spatial databases is Google Maps. When you use Google Maps to get directions, find nearby places, or check traffic conditions, all of the data is stored and managed in spatial databases. Google Maps use spatial database and queries to figure out the best routes, calculate travel times, and even provide real-time traffic data by analyzing geographic patterns. So to summarize, spatial databases are optimized for storing, query, and manipulating geographic and spatial data, making them ideal for GIS, location-based services, mapping apps, and geospatial analytics. PostGIS, Oracle Spatial, Microsoft SQL Server Spatial, and SpatialLite are just a few examples of spatial databases used in the industry. And of course, Google Maps is a great real-world example of a spatial database in action. And that's wrap on today dive into databases. I hope you find this breakdown helpful. If you enjoyed this video, don't forget to hit the like button, subscribe, and turn on the notification bell. Also, let me know in the comment section down below what's your favorite database. Thanks for watching, and I'll see you in the next one. Stay curious, keep learning.